Our next topic is a series RLC circuit connected across supply కి across గా ఆ సిరీస్ RLC సర్క్యూట్ ని కనెక్ట్ చేసినట్లయితే అంటే రెసిస్టెన్స్, ఇండక్టెన్స్, కెపాసిటెన్స్ ఈ మూడు ఎలిమెంట్స్ ప్యాసివ్ ఎలిమెంట్స్ కి across గా ఒక పవర్ సప్లైని కనెక్ట్ చేసినప్పుడు as a resistance is 10 ohms and inductance is 1 millihenries and capacitance 1000 picofarads, not a microfarads, picofarads. Picofarads means 10 to the power of pico means 10 to the power of minus 12. So 1000 into 10 to the power of minus 12. Calculate and obtain the values of resonant frequency and quality factor Q factor and half power frequency. సో ఆల్రెడీ మనము రెజొనెంట్ ఫ్రీక్వెన్సీని క్యాలిక్యులేట్ చేసాం, క్వాలిటీ ఫ్యాక్టర్ని కూడా క్యాలిక్యులేట్ చేసాం. ఇండివిజువల్గా 1 or 2 మార్క్స్ క్వశ్చన్స్లో సాల్వ్ చేసాం. ఇప్పుడు అవన్నీ కలిపి ఒక కంబైన్డ్గా ఒక లాంగ్ ఆన్సర్లో సాల్వ్ చేయబోతున్నాం. ఎక్స్ట్రాగా మనకి హాఫ్ పవర్ ఫ్రీక్వెన్సీ అనేది యాడ్ అయింది, అంతే, అంతకుమించి ఇంకేం లేదు. చాలా డెడ్ ఈజీ. డైరెక్ట్ ఫార్ములాస్లో మనము వాల్యూస్ని సబ్స్టిట్యూట్ చేసుకున్నట్లయితే కనుక మనకి అన్ని వాల్యూస్ డైరెక్ట్గా వచ్చేస్తాయి అన్నమాట. So here I have drawn RLC circuit, series RLC circuit across power supply. They connected across power supply only given, but not given how much of power supply they connected for across series RLC circuit. Okay, so no need power supply for us. So we have enough passive elements values only. That's enough to calculate these three factors. Then we'll go for given data. Resistance R equal to 10 ohms and inductance L equal to 1 millihenries. So 1 into 10 to the power of minus 3 and capacitance E equal to 1000 picofarads. So that is equal to 1000 into 10 to the power of minus 12 farads. First we are going to calculate resonant frequency FR equal to how much and quality factor Q is equal to how much and half power frequency F1 F2 equal to how much. So here half power frequency having two values. One is a low cutoff frequency F1 and a higher cutoff frequency or upper cutoff frequency F2. So here we have to take one proper frequency arrangement in a x-axis. So F0, F1, F2. So this is the frequency levels. So in this frequency level we are going to calculate F1 as a lower cutoff frequency and F2 is a upper cutoff frequency. Okay, these two values we are going to calculate here. Resonant frequency calculation. So already we know that the formula for resonant frequency FR equal to 1 by 2 pi root LC. So for both series and parallel RLC circuit, ఒకవేళ రెసిస్టెన్స్, ఇండక్టెన్స్, కెపాసిటెన్స్ మూడింటిని సిరీస్లో తీసుకున్నా ప్యారలల్లో తీసుకున్నా దాని యొక్క రెజొనెంట్ ఫ్రీక్వెన్సీ ఎఫ్ఆర్ ఈక్వల్ టు ఫార్ములా 1 by 2 pi root LC, అది కాన్స్టెంట్గా ఉంటుంది. సో హియర్ 1 by 2 pi ఆల్రెడీ ఎల్ గివెన్. హౌ మచ్ గివెన్? ఎల్ 1 into 10 to the power of minus 3 and capacitance also given, that one is 1000 into 10 to the power of minus 12. Those two values we can substitute here. Directly we can get resonant frequency FR equal to 15,954.4 hertz. That one is a resonant frequency. Then we'll go for quality factor Q. So already we know that bandwidth BW equal to resonant frequency by quality factor Q. So from that equation we are going to solve quality factor Q equal to resonant frequency by bandwidth. Here we know resonant frequency value and quality factor we need to define. First we need a bandwidth. Without bandwidth we don't have a possibility to calculate quality factor here, because here we have only one value, that one is a resonant frequency. We don't have a bandwidth value, so that's why first we are going to calculate bandwidth value. So bandwidth equal to R by 2 pi L. These are the formulas, are standard formulas. We need to always remember and we need to practice it, all the formulas, then only it will be possibility to gain the values. Whatever the values they given, then we can solve those values by using these formulas only. Okay, then bandwidth equal to R by 2 pi L. So R given, how much given? R 10 ohms, resistance given 10 ohms, and 2 pi L given 1 into 10 to the power minus 3. We can substitute those values. We can get bandwidth is 1591.54. I mean 54. That one is bandwidth. Then we can substitute values. Q equal to resonant frequency, already we have calculated, that one is 15,99,154.94 hertz. That one we can substitute FR place here. FR equal FR by bandwidth. No? So bandwidth right now we have calculated 1591.54. We can substitute those values. Then we can get quality factor Q equal to 100. So 100 we can get quality factor, in the sense this one is a very good quality factor. Yeah, so in this, according to these values. Okay, then we'll go for half power frequency F1 and F2. So lower cutoff frequency F1 equal to, so we need a lower cutoff frequency, in the sense from the resonant frequency we can subtract R by 4 pi L. So how we can got 4 pi FL, in the sense, so that one is a standard formula, so related to that lower cutoff frequency. Then F1 equal to 15 lakh, already we know that FR value is 15,09,154.94 minus 10 by 4 pi into inductance is 1 into 10 to the power minus 3. Directly we can substitute all the values. We can get 15,08,359.16 hertz. That one is a lower cutoff frequency. For upper cutoff frequency, we can addition R by 4 pi L for resonant frequency. So upper cutoff frequency F2 equal to FR plus R by 4 pi L. Lower cutoff frequency, in the sense FR minus R by 4 pi L. Upper cutoff frequency means FR plus R by 4 pi L. So we can substitute F2 equal to 15,09,154.94 plus 1 resistance 10 by 4 pi into 1 into 10 to the power minus 3. Then we can get F2 upper cutoff frequency 15,09,950.714 hertz. So this is the final value of this problem. Okay, then we have solved completely first resonance frequency and the next quality factor, then next lower cutoff frequency, and then upper cutoff frequency.